Hi everyone. Today I'll explain physical quantities in Advanced Subsidiary Physics syllabus. Physical quantities. All physical quantities have a numerical value and a unit. The numerical value tells you how much of the physical quantity there is, and the unit tells you what the physical quantity is. For example, if I say I have 3 apples, the numerical value is 3, and the unit is apples. Similarly, in physics, when we measure something, like the length of a table, we use a number and a unit. The number tells us how long the table is and the unit tells us what the measurement is in, for example, 3 meters or 5 feet. It's important to always include the unit when measuring or reporting a physical quantity because it gives context to the numerical value and allows for accurate comparison or conversion with other measurements. Quantitative versus qualitative. Most observations in physics are quantitative. Descriptive observations, or qualitative, are usually imprecise. Qualitative observations: how do you measure artistic beauty? Quantitative observations: what can be measured with the instruments on an airplane? A physical quantity is one that can be measured and consists of a magnitude and unit. Measuring length. SI units are used in scientific works. Physical quantities are classified into 2 types. Base quantities, derived quantities. Base quantity, for example, is like the brick, the basic building block of a house. Derived quantity, for example, is like the house that was built from a collection of bricks, basic quantity. Base quantities are the quantities on the basis of which other quantities are expressed. The quantities that are expressed in terms of base quantities are called derived quantities. SI units for base quantity. SI units, International System of Units. Base quantities, name of unit, symbol of unit. Length meter m. Mass kilogram kg. Time second s. Electric current ampere. Temperature Kelvin K. Amount of substance mol. Derived quantity and equations. A derived quantity has an equation which links to other quantities. It enables us to express a derived unit in terms of base unit equivalent. Example: F equals m multiplied by A, Newton equals kilogram meter per second squared. P equals F divided by A, Pascal equals kilogram meter per second squared per m squared equals kilogram per meter per second squared. SI units. 1. Equation: area equals length times width. In terms of base units, units of area equals meter times meter equals meter squared. 2. Equation: volume equals length times width times height. Units of volume equals meter times meter equals meter cubed. Density equals mass divided by volume. Units of density equals kilogram per meter cubed.